We are going to start Chapter 3, Numerical Solutions to Equations.
Okay.
The 3.1 is locating roots. This is the same as the first topic of Chapter 8, P3, Chapter 8, Numerical Methods. It's exactly the same. Okay. Now, probably I will explain the method first. Let's say you have a function f of x. This is the graph representing the function, and the graph is crossing x-axis here. So when you find the value of the function at this point, you will get f of a here, which is a positive value, right?
Yeah.
And you find the value of the function at the b after the crossing, then the corresponding value will be here, which is going to be a negative value f of b, right?
Yeah.
The value of the function changes from positive to negative. If the graph is this way, the value is going to change from negative to positive. So when the value of the function changes from positive to negative or negative to positive, we can say there exists at least one crossing in between the points, right?
Yeah.
But in mathematical terms, we don't say crossing, we say there is a root for this function f of x is equal. There is a solution to this equation, or we can say f of x has at least one root between these 2 points, right?
Yeah.
Why we use the word at least one root? I'll give you another scenario now. Let's say the point A is here. Let's say this is the graph. Okay. The value of the function a would be f of a here negative. The value of the function b would be f of b positive. The sign changes from negative to positive, but as you can see, there are 3 roots in between. So we can say there exists at least one root. There exists at least one root between these 2 points, right?
Yeah.
There are some special cases here. For example, look at this function. Look at this function. If you take a point A and B here, both will give you negative value, right? When you sub in into the function. But still there are even number of roots, correct?
Yeah.
Okay. So even though there is no change of sign here between A and B, still there are roots. Correct? And I'll give you one more scenario. Look at this reciprocal function. If you take a value a here, the function value will be negative. If you take a b here, the value of the function would be positive. There is a change of sign, but there is no roots in between the points, right?
Yeah.
Correct. These are all the special cases actually. So usually, what type of question you will get from this topic? I'm going to take a question from exercise 3a. Show that each of these functions has at least one root in the given interval. So this is how you need to solve it. If you get this question, for example a, you have the interval given -2, -1, right? Find f of -2 first. -2 whole cube -1 plus 5, right? It is -8 minus of -2 plus 5. So you get -8 plus 7 is -1. You have to write is less than 0. And then find f of -1. -1 cube x cube minus x plus 5. You'll get 6 minus 1 5 is positive, right?
Yeah.
So this is how you write the conclusion now. Therefore there is a change of sign. There is a change of sign, and f of x is continuous. We will usually write this in P3 numerical methods. If you don't write this, you will lose more. But here in FP1 textbook, they don't care about this one. They just want you to write there is a change of sign. Okay. So probably we can just leave it. There is a change of sign, therefore there exists at least one root. There exists at least one root between one root in the interval, one root in the interval -2 to -1. Understand?
Yeah.
That's a change of sign rule. So you need to make sure you put it in your calculator and double check whether there is a change of sign. Okay, now if you come across a trigonometric function, you are going to replace x by some real numbers, right?
Yeah.
So you need to make sure your calculator is in radian mode. Okay?
Yeah.
Now I'll show you one more question now. For example, take D. The interval is 1.65, so f of 1.65 and f of 1.75 is equal to, you need to show them your sub in the value ln 1.65 minus 5 e power 1.75 minus ln 1.75 minus 5. Let's sub in these values in the calculator. E power 1.65 minus ln 1.65 minus 5. We get a negative number minus 2.39 minus 2.3924 dot dot dot. You don't need to round it, okay? Just mention is less than 0. I'm gonna change 1.5 to 1.65 to 1.75 now. So I'm getting a negative number for some reason. E power 1.75 ln 1.75 minus 5. Supposed to be a positive number. So something is wrong probably. I'll just rewrite in e to the power 1.75. The question says show, sorry?
I get 0.194.
You got a positive number, right?
Yeah.
Yeah, I think I made a mistake somewhere here. Yes, 0.194, 0.194 dot 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 and positive number, right? And then you need to write the conclusion. There is a change of sign. There is a change of sign. Therefore, you can write it this way also. F of x has at least one root in the interval minus positive 1.65 to 1.75.
Yeah.
That's how you write the conclusion. Understand?
Yeah.
Let's look at this question now. So always remember, if there is a trigonometric function involved, you have to keep the calculator in radian mode. Here f of x is equal to this function given 3 plus x square minus x cube. Show that the equation f of x has a root in the interval. So as usual, we need to check the change of sign rule. So find f of 1.8, which is 3 plus 1.8 square minus 1.8 cube, and then f of 1.9, which is 3 plus 1.9 square minus 1.9 cubed. Let's find these values. 3 plus 1.8 square minus 1.8 cube. 0.408, isn't it? It's a positive number. I'm gonna change 1.8 to 1.9. I get a negative number 249, negative 0.249. You need to show them it's less than 0. And then write the conclusion. There is a change of sign, therefore f of x has at least a root alpha. You need to mention at least a root alpha in the interval. You can just write this as a conclusion. Okay, I'm going to show you part B now. If you read part B, the solution is given here already. 1 point alpha is equal to 1.864 is given already. By considering a change of sign of f of x in a suitable interval, you need to find the interval now. The interval is not given. How to find the interval? Just find the lower bound and upper bound of this. That means there are 3 decimal places here, right? So you put 3 zeros and 5. 3 zeros and 5. You add and subtract. You'll get 1.8635. 1.8645. That's how you get the interval, understand?
Yeah.
Now find the value of the function at these 2 points. 8635, f of 1.8645. That's going to be 3 plus 1.8635 square minus 1.8635 cubed. Here 3 plus 1.8645 square minus 1.8645 cubed. Let's get these values. So 3 plus 1.8635 square minus 1.8635 cubed. You get a standard form sometime in the calculator. I don't know the calculator you are using is giving you the actual number or not, but if you get a standard form, you still need to write it as a proper number. I'm getting a number 1 point something something times 10 to the power minus 3. So I'm gonna put 2 zeros. This value is 0.0013 etc. positive number. I'm gonna change now 8635 to 8645 now. 8645. I get a negative number. Again standard form, so I write it as 0.0000531 etc. is less than 0. Right? So now you need to write the conclusion. How to write the conclusion? You need to write there is a change of sign. There is a change of sign. Therefore alpha lies between 1.8635 and 1.8645. Therefore alpha is equal to, write the value from the question, the highlighted one, 1.864 to 3 decimal place, 1.864 to 3 dp. Understand?
Yeah.
So here we are finding the interval by using the method we learned for finding the upper bound, lower bound and upper bound. If you see 3 decimal places, you put 3 zeros and 5, add and subtract. Understand?
Yeah.
Let's look at one more question. Now the question has a trigonometric function involved, so you need to make sure your calculator is in radian mode. Show that the equation f of x has a root. So you need to find h of 1.4, which is cube root of 1.4 minus cos 1.4 minus 1. H of 1.5 is cube root of 1.5 minus cos 1.5 minus 1. Let's keep the calculator in radian mode first. Number 4. Now we need to type cube root of 1.4 minus cos 1.4 minus 1. So you get a negative number, 0.0512 minus 0.0512 etc. etc. You don't need to write all the decimal numbers less than 0. and then I'm going to change 1.4 to 1.5 now. So I get a positive number 0.0739, 0.0739, etc. is greater than 0. And then you need to write the conclusion. You know what to write, right? There is a change of sign, therefore you just write this whole thing. F of x has at least one root alpha in the interval 1.4 between 1.4 to 1.5. Understand?
Yeah.
Part B, alpha is equal to 1.441. Can you tell me what would be the lower bound and upper bound? What you need to add and subtract?
0.0005.
0005. You add and subtract. So what would be the value?
4415 and 4405.
4415, 4405. Now find the value of the function at these 2 points. H of 1.4415, and then you need to write the conclusion. There is a change of sign, blah blah blah. 1.4405, 4405, 4405. I get 10 to the power minus 4, so 554, 0.00055, etc. is a negative number. But you see, you don't just straight away write the value after this. You need to show a step like this one, how you sub in the value, right? You need to show that step, then you write the value. Okay, we have done that for the previous sum here, right?
Yeah.
You see, this is how you need to show the step and then the value. So I'm skipping that step here, but when you write in the exam, you have to write that step.
Okay.
And I'm gonna change it to 4415. I get a positive number 698, 0.000698, etc. is positive. Write the conclusion. There is a change of sign, therefore the alpha lies between these two values. And then finally you write alpha is equal to, take it from here, 1.441. Do you understand this method?
Yeah.
Look at this question. Show that, part A, show that f of x changes sign in the interval. So you just need to keep the calculator in radian mode and find f of 1.5 and f of 1.6. You will see the sign changes from positive to negative or negative to positive. That's just a normal method we discussed in the previous questions, right?
Yeah.
But part B, state with the reason whether or not f of x has a root in the interval 1.5 to 1.6. Okay, let's look at this graph. Remember in P1 we learned the tan graph.
Yeah.
I'm going to sketch the graph here. This is pi over 2 where you have asymptote, and then 2 pi over 2. You will have only the top part of the graph here and the bottom part here. This is tan x. And when you add 2, we learned this in P1 chapter 4, graphs and transformations.
Yeah.
The graph will go up, right?
Yeah.
So the graph will go up 2 units, something like this, right?
Yeah.
Correct. But still the pi over 2 is an asymptote, right?
Yeah.
Okay, now we need to check whether this value is on both sides of pi over 2, right?
Yeah.
When you find the value of pi over 2 in your calculator, pi divided by 2, you get 1.57. So you need to write x is equal, for part B, x is equal to pi over 2 is 1.57, etc., etc. which lies between these two values, right?
Yeah.
So what does that mean?
So there's no root.
There is no root, therefore there is no root in the interval 1.5, 1.6. Understand?
Yeah.
1.5 will be here before pi over 2, 1.6 will be after pi over 2. But when you find the function value, of course you are getting change of sign, but the graph is not crossing between these 2 points. Understand? Next question. On the same axis, sketch the graphs y is equal to square root of x and then 2 over x. Okay, remember this is the graph for square root of x. This is square root of x. Y is equal to square root of x. And then we learn the reciprocal graph in P1, right?
Yeah.
The 1 over x is going to be a piece here, another piece here. That's 1 over x or 2 over x. Y is equal to 2 over x, right? With reference to your sketch, explain why the equation square root of x is equal to 2 over x has exactly one root. Because why? Because there is only one point of intersection, right?
Yeah.
There is only one point of intersection of these two graphs. When they put these functions equal, they are talking about point of intersection, right?
Yeah.
So that's the equation has only one root. Is that clear?
Yeah.
So we are going to move on to part C of this now.
Okay.
F of x is equal to square root of x minus 2 over x. Show that the equation has a root r in the interval 1 to 2. So same like before, you need to find f of 1, which is square root of 1 minus 2 over 1, which is 1 minus 2. Now f of 2 is equal to square root of 2 minus 2 over 2. Square root of 2 minus 2 over 2. You get positive number 414, etc. So you need to write the conclusion. There is a change of sign. Therefore, the root r f of x is equal to 0 has a root r between 1 to 2. Is that clear?
Okay. Yeah.
So conclusion all you can write it. D now. Show that the equation can be written in this form: x power p is equal to q. So let's take the equation square root of x is equal to 2 over x. Square both sides. When you square both sides, you will get x is equal to 2 square by x square. Bring the x square here. X cube is equal to 4. That's it. Easy, right? P is equal to 3. Q is equal to 4. Right?
Yeah.
Hence, write down the exact value of the root of this equation. What we can do here, multiply throughout by x, you will get x power 3 over 2 minus 2 is 0. X power 3 over 2 is 2. X is equal to 2 power 2 over 3. 2 power 2 is 4. You can write it as cube root of 4. That's the exact solution. Understand?
Yeah.
Let's look at question number 7. F of x is equal to x power 4 minus 21 minus 8. I'm gonna skip part A because you just need to sub in the values. Make sure there is a change of sign, right?
Yeah. Yeah.
Okay. Part B says find the coordinates of any stationary point of the graph. The moment the question talks about stationary point, we need to differentiate it and equate it to 0. Alright?
Yes.
So you will get 4x cube minus 21 is 0. X cube is 21 over 4. X is cube root of 21 over 4, right? And then sub in the value into the function to find the y coordinate. So f of, I'm going to find this value, cube root of 21 over 4. cube root of 21 over 4 is 1.738, etc. This is 1.738, etc. Okay, I'm gonna use the exact value, not the rounded figure. I'm gonna use the exact value in f of x. So f of 1.738, etc. is 1.738, etc. power 4 minus 21 times 1.738, etc. minus 80. That will give you the y coordinate. So in the calculator, I'm gonna store the value as a. Now a to the power 4 minus 21 times a minus 80. So I get minus 45.373 dot dot dot. They did not mention any level of accuracy, so I'm going to round it to 3 significant figure. Therefore the stationary point is 1.74 comma minus 45.4, 3 significant figure. Understand?
Yeah.
Okay, now let's move on to part C of the question. Given that f of x is this, find the value of the constants. Okay, you just need to equate the f of x, x power 4 minus 21x minus 18, right? Yes.
Yeah.
Equate it to x minus 3 times x cube plus ax square plus bx plus c. You can do one more thing. The method I'm going to apply is comparing the coefficient. You can take this and divide this using long division method. You will get a cubic function here. Compare it and find ABC. That's another way of doing it. Understand?
Yep.
So here I'm going to compare the coefficient. When you compare the coefficient of x cube both sides, we don't have x cube on the left hand side, but when you multiply these two, you'll get ax cube, so the coefficient is a. You multiply these two, you'll get minus 3x cube minus 3. That gives us a is equal to 3. There's another way of finding ABC. Okay, comparing the coefficient. You understand this?
Yeah.
I'm going to compare the coefficient of x square now. There is no x square here. 0 is. You will get bx square, so b, minus 3ax square, so minus 3a. Sub in the value of a here. B minus 9 is 0. B is equal to 9. And then I'm going to sub in x is equal to 0 on both sides of the equation. So this becomes 0. This becomes 0. Minus 18 is equal to 0. So you'll get just minus 3 here. Here it's 0, 0, 0. You'll get just c. Understand?
Yeah.
So c is equal to minus negative 18 over negative 3. You get 6. Okay. Part D, sketch the graph. Sketching the graph, a function of degree 4, is not in our syllabus. Okay. So what you can do, you can just use the desmos.com to sketch the function. So I'm just going to show you the function. I'm not going to explain much about this function because there are different types of function with degree 4. But here what you need to understand, the graph has a crossing at this point, minus 0.9, minus 0.8. Okay?
Yes.
And it has a stationary point. So the graph is gonna look like this. It's not a parabola, it's more like a skewed one. You mention the point here, 1.74, the stationary point, 45.4 minus 45.4, and then mention negative 1.9, negative 1.8 here, origin. Understand?
Yeah.
That's the graph.
Okay.